So I'm just going to talk about some of what we're doing in hydrogen, and there was also an inquiry about one of the projects we have in South Africa, which is relevant to what we're doing in Singapore. So hydrogen will play a role in decarbonisation, and there are specific areas where hydrogen will play a significant role. Marine is one, and the other is going to be flight, meaning long-distance aircraft, because you will find it extremely difficult to replace kerosene as jet fuel. So here we talk about some of the initiatives that we're looking at in those two areas. So we have a hydrogen barge design, which we are looking to develop in the next 2 to 3 years into a concept plant that will bunker hydrogen on water. So to produce hydrogen, you need electricity and you need water. So the idea with the barge is to just connect to the electricity, because you're on the water source and you can produce on-site hydrogen for small and medium craft. And we think that this is a scalable and replicable business model that can be applied to other areas. So this is the barge design that we looked at. So this is going to go through a certification process to be certified. But essentially, as you can see, you can dispense hydrogen to shore or to the vessels in the port. And vessels that cannot use batteries, for example, that have tugboats that need a very high energy density, and some other vessels, because of health and safety, they may not be able to carry lithium-ion batteries. We will have a use for hydrogen. So hydrogen is going to be a small portion of port and marine vessels, but not. It will be dominated more by batteries and direct electrification. So that's where we're focusing on as the market. So in terms of, everyone talks about hydrogen safety. So hydrogen can be very safe, and there's a lot of technologies that can be used today to ensure that hydrogen can be safe. And the first one to look at is we will have a lot of sensors and fail-safe mechanisms to ensure that there'll be automatic shut-off procedures, and also the vessel can be remotely operated, so we will not need to have on-site people who don't necessarily need to be there. We're also investigating robotics for the dispensing of the hydrogen. So it can be very safe, and if you think of the applications to ports globally, if we can prove this concept and in Singapore as a benchmark port in the world, this could be a very good solution for decarbonizing import marine. So this is what can be looked at. We can also put a fuel cell on board, so if vessels come in and they need shore power, we could look at supplying shore power, or look at backup power or other solutions as well. So these are just some of the options. So as I mentioned, it's for niche decarbonization in certain areas in the port. So this is the process flow of what would happen. So we do need to connect to renewable electricity, and we recognize that in Singapore, renewable energy credits are very high, but this is a pilot to then be able to test bunkering and go through the process of certification for bunkering in port. As the project expands, we will look to bring in imported ammonia, which we can then crack back to hydrogen, which will be a lot more price competitive. But we need to start on a small scale, and hydrogen is always stuck in the chicken and egg situation about whether you build a hydrogen infrastructure first or you get the customer to convert the engine. So we work on both of those initiatives together in a small scale project. So in terms of where does the MPA and the Energy Market Authority see the energy transition? So these are public documents that you can view. So you'll see that hydrogen is part of the long-term future, and so is ammonia and methanol. And hydrogen is seen as one of the options. So that's what we're focusing on, is the hydrogen opportunities which are part of the decarbonization plan. So And then just to recap is that hydrogen and what you'll get is ammonia and e-methanol will play a role alongside other technologies. And really the big drivers of decarbonization will actually be energy efficiency and direct electrification and batteries. And then the balance will be with hydrogen technologies. So in terms of the history of the barge, we did a pre-feasibility in 2020 and we won a UK Innovation Award. And then we did a feasibility study with a marine engineering company called Longitude. And the project was recognized at COP26 and working with Singapore and MPA and Jurong Port to get a port location is what we are discussing at the moment. We also have a project. So we have worked with Cyclect since 2021, looking at the only operating hydrogen project in Singapore, and that's on Samako Island. So we both now have got credentials in Singapore in hydrogen, and we have used that to look at other opportunities. We are developing a ammonia project, and I can talk a little bit about that afterwards, in South Africa to export the ammonia to Singapore. So it's very well located on the east coast. That area has very good solar and very good wind potential, so the renewable energy costs are very low. And then we were part of the PIA 71 program to look at at innovation in marine. So to get to decarbonization, the strategy for us is to use the small bunker pilot to then look at how you can scale up to look at green ammonia and methanol later on and move to larger vessels. And that's a very good trajectory because we're learning by doing rather than making really big investments without having the technology validation. So that's on the marine side. We also are looking at some projects and what developments that are happening in flight. And I just thought, so this is very interesting to see that to replace petrol, diesel and kerosene, if you look at the energy density per liter, they are quite high relative to a lot of the other potential energy sources. And when it comes to flight, if we go to, or when we go to other fuels like hydrogen in the future, that the aircraft will need to be redesigned. So there's a lot of work being done globally amongst Boeing and Airbus to look at how you redesign aircraft to accommodate those fuels. So battery, electric and hydrogen combustion and hydrogen fuel cells will play a role in decarbonization, but it's very difficult to see for long-haul flights a significant change. It's expected that up to a third of fuels may come from hydrogen-related technologies in the future. So we have a long journey to do when it comes to decarbonizing flight. But hydrogen will be one of the potential solutions. So these are some of the aircraft designs from Airbus that are looking at hydrogen. And basically it involves, because you need a larger storage space for the fuel to meet the same range that you would get from kerosene, the aircraft too requires significant redesigns, which could also mean you need to change infrastructure in airports and other areas. So that's yeah, and then this is just to give you an idea. For Singapore, aviation is extremely important. It's one of the busiest airports and contributes a significant portion of GDP. So decarbonization of flight and flight tourism and things like that is quite important to Singapore. Yeah, and I think, so that's our presentation, and it just gives you an idea of how hydrogen will play a role in marine and flight decarbonization. Thank you.